You open an app, you find the headphones you wanted, you tap, pay $999. For a second, nothing happens. The screen just sits there, thinking. Then, 3 seconds later, payment successful. You move on with your day. You don't think about it again. But what actually happened in those 3 seconds? Because here's the truth. In that tiny gap between your tap and that green check mark, your request traveled through banks, security systems, fraud detectors, and data centers scattered across cities you've never visited. Multiple companies that have never met you decided, in real time, that you are who you say you are, and that your money is good, and you never saw any of it. This is the story of what really happens when you pay online. Not the version on the screen, the version underneath it. Let's start with something that sounds obvious but isn't. When you pay online, money does not simply move. Your bank doesn't reach into a vault, pull out cash, and hand it to the seller. There is no vault, there is no cash. What actually happens is closer to a negotiation between institutions, one that has to happen perfectly every single time in under 3 seconds. To understand how strange that is, you have to understand every player in this invisible chain. Your phone, the internet, encryption, a payment gateway, at least 2 banks, a payment network, a fraud detection system, and finally, a settlement process that finishes the job hours or even days later. That's the journey. Now let's follow it, one chapter at a time. What an online payment actually is? An offline payment is simple. You hand over cash or you tap a card at a machine that's physically wired to a bank. Everyone in the room can see it happen. An online payment has no room. There's no physical handshake, no paper trail you can watch. Instead, there's a request, sent as data, asking a question on your behalf. Does this person have the money, and are they allowed to spend it here? That single difference, no physical presence, is why online payments need so much more machinery than a cash exchange. Every layer you're about to learn about exists to solve one problem. How do you trust a stranger you cannot see in a transaction that has to complete in seconds? The many ways you can pay. Not every payment method takes the same road. A UPI payment in India moves bank to bank almost directly, using something called a virtual payment address instead of an account number. A credit card payment borrows money from the bank issuing your card to be paid back later. A debit card pulls directly from your existing balance. Net banking logs you straight into your bank's own portal. Digital wallets, like a prepaid account sitting between you and your bank, hold a stored balance you top up in advance. Buy now, pay later services quietly run a mini credit check and split your payment into future installments. Contactless and NFC payments, the tap-and-go kind, use short-range radio signals to send encrypted card data from your phone or card to the merchant's terminal without either of you touching a keypad. Different roads, same destination. An answer, in seconds, about whether this payment can happen. The moment you click Pay Now, the instant you tap that button, your device doesn't send your card number floating across the internet in plain text. It packages your payment details, amount, merchant ID, a securely generated version of your card or account information, into a structured digital request. That request gets encrypted, meaning scrambled into unreadable code, and sent out over the internet toward its first stop, the payment gateway. Think of this moment as writing a sealed letter. You're not shouting your card details across a room. You're sealing them in an envelope only the right recipient can open and handing that envelope to a courier who has one job: get it there safely and fast. The payment gateway. The quiet translator. Here's something that surprises most people. The website or app you're buying from almost never touches your actual card details directly. Instead, it hands the job to a payment gateway, a company like Razorpay, PayU, or Stripe, whose only role is translation and forwarding. The gateway takes your very human transaction, a pair of headphones, $999, and converts it into a rigid, standardized format that banks and networks can process. It doesn't hold your money. It doesn't decide whether you can pay. It's a courier and a translator rolled into one, existing so that individual merchants never have to build their own direct, secure connection into the banking system. Why would a small headphone shop need to talk to your bank at all? It shouldn't. That's the gateway's job. Encryption and security. The sealed envelope. Now, how does that sealed envelope actually stay sealed? This is where HTTPS and TLS come in, the invisible protocols responsible for that small padlock icon in your browser. In plain terms, TLS creates a private tunnel between your device and the gateway's servers so that even if someone intercepted the data mid-transit, all they'd see is scrambled noise. Underneath that is public key encryption, a system where two mathematically linked keys exist, one public, one private. Your device can lock information using a public key that anyone can see, but only the intended receiver holding the matching private key can unlock it. It's like a mailbox anyone can drop a letter into, but only the owner has the key to open it. And increasingly, your actual card number never travels at all. Through a process called tokenization, your 16-digit card number gets replaced with a random, meaningless token, valid only for that one transaction on that one device. If someone intercepted it, they'd steal a value that's useless anywhere else. This one idea, quietly rolled out over the last decade by card networks and standards bodies like EMVCo, has done more to cut down online card fraud than almost any visible security feature you've ever noticed. The banks behind the scenes? Once your request reaches the gateway, it gets forwarded toward the banking side of the chain, and here, there are actually two banks involved, not one. The issuing bank is your bank, the one that gave you the card or account. The acquiring bank is the merchant's bank, the one that will eventually receive the money on the seller's behalf. Your issuing bank is the one doing the real interrogation. Do you have enough balance or credit available? Is your card active and not expired? Does your PIN or password check out? Have you hit a daily spending limit? Does this transaction look unusual for you, geographically or in amount? All of this happens through automated systems that respond in a fraction of a second, because a human reviewing every transaction manually would make online shopping take days, not seconds. Payment networks, the invisible highways. But how does your bank even talk to the merchant's bank? They're not directly connected. That's the job of payment networks, Visa, Mastercard, RuPay, and in India's case, UPI's own network run by NPCI. These networks don't hold your money, ever. They're routers, enormous, redundant systems whose only purpose is to carry that authorization question from the merchant's bank to your bank and carry the answer back without losing a single request. Even when hundreds of millions of transactions are happening at once, somewhere on the planet, right now, UPI, a different kind of highway. UPI deserves its own moment because it works differently, and it's arguably the most revolutionary payment technology to come out of India. Instead of routing through card networks, UPI connects banks almost directly using a virtual payment address, something like a nickname that stands in for your actual account number. Scan a QR code, and you're really just pointing your bank straight at another bank, with NPCI's UPI infrastructure acting as an instant interoperable switchboard. Any bank can talk to any other bank in real time because they all speak the same standardized language. That's why a QR code outside a tiny fruit stall can work with literally any UPI app, regardless of which bank either person uses. It's not one company's product. It's a shared national utility, and that shared design is exactly why it feels almost instant. There's no waiting on batch processing between different networks. It's closer to a live conversation than a mailed letter. Authentication, proving you are you. Somewhere in this chain, the system has to confirm you're actually the one authorizing this, not someone who stole your phone. That's what OTPs, PINs, CVVs, passwords, and biometrics are for. Each one covers a different weakness. A password proves you know a secret. An OTP proves you currently hold your registered phone. A fingerprint or face scan proves you are physically present. A CVV proves you're holding the physical card, or at least once did. No single method is foolproof alone, which is exactly why modern payments often stack two or three of them together. This layering is called multi-factor authentication, and it exists because a thief might guess a password, but is far less likely to also have your phone in hand and your fingerprint at the same moment. Fraud detection. The silent watchers. While all of this happens, another system is quietly running in the background, one you never interact with directly: fraud detection. Banks and networks feed each transaction through models trained on billions of prior payments, checking your location, your device, your usual spending habits, the merchant you're buying from, the time of day, the amount, and how frequently you've been transacting. If you always shop from Mumbai and suddenly a transaction appears from a country you've never visited, the system notices. Not because a person is watching your account, because a person couldn't possibly watch fast enough. These are machine learning models quietly scoring risk in milliseconds, deciding whether to wave a transaction through or flag it for extra verification. Authorization, the final green light. Once your bank checks your balance, your identity, and your risk score, it sends back a response, an approval or a decline, traveling back through the same chain: network, acquiring bank, gateway, merchant, and finally, your screen. Sometimes you'll see a decline for reasons that have nothing to do with fraud: an expired card, a technical timeout, a temporary duplicate transaction block designed to stop you from being accidentally charged twice. All of this, every check, every handoff, completing in the time it takes to read this sentence: why payments sometimes fail. And here's a question you've probably asked out loud at some point: why did my money get deducted but the merchant never got it? The answer usually lives somewhere in this chain, breaking quietly. Maybe your internet connection dropped mid-transaction. Maybe the bank's server was under heavy load. Maybe the payment gateway itself timed out. Maybe the payment network was congested. In these cases, the money often does leave your account temporarily, held in a kind of limbo, before automatically reversing back to you once the failure is detected. It's not usually fraud. It's usually just one weak link in an enormously long chain, a link that has to hold up perfectly every single time across millions of simultaneous transactions. Settlement, the part that happens after the checkmark. Here's the part almost nobody realizes. That green "payment successful" message you see isn't the money actually landing in the merchant's account. It's authorization, a promise that the money will move. The actual transfer, called settlement, usually happens later, often in batches, at the end of the business day. Banks don't move every single transaction individually in real time between institutions. That would be wildly inefficient. Instead, they net out thousands of transactions against each other during a process called clearing and settle the final balances later. This is why a merchant might not see funds in their account until a day or two after your purchase, even though your payment was successful instantly. Authorization is the promise. Settlement is the delivery, the infrastructure nobody sees. Behind every one of these steps sits an entire physical and digital world most people never think about. Data centers, buildings full of servers, kept running 24 hours a day, spread across multiple locations so that if one fails, another instantly takes over. Fiber optic cables, some running under oceans, carrying your transaction data at close to the speed of light. DNS systems quietly translating web addresses into locations computers can find. APIs, standardized digital doorways that let a payment gateway, a bank, and a card network, all built by different companies on different systems, still understand each other perfectly. Load balancing spreads incoming transactions across thousands of servers, so no single machine gets overwhelmed. Disaster recovery systems keep backup copies of everything, ready to take over the instant something breaks. None of this is visible to you. All of it has to work simultaneously for that 3-second payment to feel effortless. Where all of this is heading? So where does this invisible machinery go next? Fraud detection is getting sharper, powered by AI models that learn new fraud patterns almost as fast as criminals invent them. Biometric payments, palm scans, facial recognition are already being tested at checkout counters in several countries, aiming to remove cards and phones from the equation entirely. Offline digital payments are being developed for regions with unreliable internet, letting your phone confirm a transaction even without a live connection. Central banks, including India's, are piloting programmable digital currencies, government-issued digital money that could carry built-in rules about how and where it's spent. Even encryption itself is being redesigned in anticipation of quantum computers powerful enough to one day break today's locks. And increasingly, AI systems are being trusted to make instant judgment calls that used to require human review, deciding in the blink of an eye whether a transaction should be trusted. Coming full circle. So, the next time you tap Pay Now and wait those 3 quiet seconds, you'll know what's actually happening. Your request gets sealed and encrypted. A gateway translates it. Two banks interrogate it. A payment network carries it across an invisible highway. A fraud model judges it in milliseconds. Your identity gets confirmed, and an approval races all the way back, through every one of those steps, just in time to become a green checkmark on your screen. That checkmark isn't the end of a simple transaction. It's the visible tip of one of the most sophisticated, quietly coordinated technological systems most people use every single day and never once think about. 3 seconds. An entire hidden financial world, working flawlessly just so you wouldn't have to.